Hey y'all, this is Pre-Calculus, and we are actually doing Algebra 2 review. We're talking about 9-7, which is period of sinusoidal functions. And I'm Mr. Sindel, so we're going to be talking about periods today from a graph. So a period is how long it takes for the entire function, sine or cosine or tangent or whatever trig function you're talking about, to repeat. How long does it take to repeat itself? That's the idea of a period. So when we look here, you can clearly tell. Are you okay, Rochelle? Oh, that's right. You need to sit over there. You can clearly tell that this sine function goes from the bottom left to the top right through this point, and that repeats over here on this point from the bottom left to the top right. I can't speak right now. So this is the period. From there to there is the entire period. So I wish I would have put some more room, but this entire distance from here to here, label this also, that is one period. One period. But I am not going to give you exactly one period. I want you to find it. And today we're talking about graphs and equations. Normally the last lessons we've been doing one and then the other. Because there's so little material, I'm just doing it all at once right now.
One question though.
Okay.
What's a period?
A period is the distance it takes to repeat.
What do you mean?
So how long does it take to start repeating the sine function? The sine function goes up, then it goes down, and then it goes back up, and it repeats all of a sudden right here. If I just cut it off and then copy and paste this over and over again, then it's starting to repeat.
So it's the first repeat?
So after the first repeat, yep. So, and I guess I should make a note to formally define a period in my future notes. But yeah, how long does it take to start the cycle again? What is that distance? So if that is one period right there, that means that the distance between here and here is how much of a period?
Half. 1/4.
Is it half or a fourth?
1/4.
It is 1/4. So let's label that 1/4 of a period. What is this distance right here?
That's the peak.
There is a peak right there. I agree. What is this distance called?
Amplitude.
There it is. This is amplitude. Amplitude. Get some review in here. What about that orange line? What's this orange line called? Yeah, that's our midline. What about this line right here, Daisy? What about this line right here? What is that distance right here? This line right here?
Oh, I don't remember.
It's the same as this line right here?
Oh, it's an amplitude.
It's an amplitude, yeah.
Oh my god. If you're gonna be sassy like that, go away. I wish I could.
All right, easy, easy, easy. We're all friends here. What about this distance right here? I'm going to give this one to Daisy because she's really smart. And she works really hard in my class. She works really, really hard in my class. You do. Especially last year. You're the hardest worker in my class. So Daisy.
Don't talk to me.
My hardworking Daisy.
No.
How much of a period is this? If this was a 1/4 of a period over here, how much is this?
Oh, I don't know, Mr. Smith.
Take a guess. Your best guess.
No, I'm pretty sure Rochelle can say it. It's fine.
But I believe in you. You can do this. No? Okay. Rochelle, you want to do it for us?
1/4.
It is another 1/4. So if I look here, and this is important, and I'm saying that because it's going to be directly transferred to what you're going to be seeing in the homework. If you look from the distance from the midline to a minimum or maximum, this one happens to be a maximum, from the midline to a maximum is 1/4. From the maximum back to the midline, it's 1/4. But what if I go from the midline to the midline? This whole distance here is how much of a period? This whole distance here, right here, is how much of a period? Yeah, there it is. Half a period. What about this distance right here? How much of a period is this distance right here? It's another half. What about this distance right here? 1/4. As a rule for what I'm going to be doing on the quiz and test and what Khan Academy is also going to do, I'm never going to do 3/4. I'm always going to do a half, a fourth, or a full. Usually a half or a fourth. Those are my favorite ones, just to be ready. But even if it was 3/4, it's the same rule over and over. So, oh yeah, go for it.
If it's 3/4, would Would it also be called 3/2?
3/4 is not 3/2. That would be the same thing as 1.5 halves if you want to reduce it. But 3/2, sorry, that's not 3/2. It would be 3/4 would be there to there for 3/4. And yeah, you can reduce it kind of, but not, I mean, that's as reduced as you get it. You could have it converted to a decimal. All right, so finding the period of a sinusoidal function, so a cosine or a sine usually. To find the period, you take the distance. Actually, you're going to multiply the distance that you found. So, for example, if I said, oh, I found that the distance between the midline and the amplitude, this maximum point, that distance is 2. You take that distance and you multiply it by the reciprocal. Reciprocal of the fraction of the period. That sounds very convoluted, and I probably could have said that better. But I can boil it down even farther. So, for example, let's say that this distance between this midline and that maximum is 2. I need to multiply that by the period, but take the reciprocal, flip it. Flip 1/4, it becomes 4. Multiply 2 by the reciprocal, 4, and that distance is 8. That means this whole thing travels 8. That whole distance here is 8. The period for it to repeat is 8 units. So take this 1/4, take that 1/4, take the 1/2, take whatever it was, take the reciprocal of that, then multiply it by the distance that you found. We're okay? We're okay, Rochelle? No? So maybe I can explain it better with an example, because we'll just be using that rule over and over. I'll be sure to make sure to explain this as best as I can. Okay, so we have a trig function, and it has a maximum right there at negative 1.8, 2.2. It has a minimum here at 1.2, 0.2. I need to figure out the period of that function. All right, well, first of all, I need to ask myself, this distance here, is it half of a period? Is it a quarter of a period? Is it the full period? How much of a period is it? Remember, the full period is how long it takes to repeat the entire thing. So a full period would be right there. That half? What do you think, Daisy? Half? I agree. So we're going to say that's a half a period. Half a period. Well, now we have to find how long that is. What is the length? The length from here to here? Well, look at the x-coordinates. The x-coordinate is negative 1.8 to 1.2. How far did I travel there? How far did I travel? And you can just do a subtraction problem. I can take the x-coordinates and I can say the right coordinate, 1.2, minus the left coordinate, negative 1.8. Oh, I have negatives kissing here. So if the negatives kiss, that's going to be plus and plus. What is it 3? Do we agree? 1 and 1 is 2. 0.2 and 0.8 is another 1. So 2 plus that other 1 is 3. We're all okay with 3? Daisy? Whoa!
Did you see that?
Whoa!
I so
did! Oh my God! Keep it PG in here. All right, so that distance is 3. So if you don't like this rule, multiply by the reciprocal. What you can't, because I know that you two said, I like rules, Mr. Sindel. If you don't like that rule, just think about it logically, right? Well, to get to the full period, I have to go from here to here. I've only gone halfway. I need to go another how many units? I've gone 3 units already. I need to go another
unit.
Another how many units?
3.
3. I need to go another 3. So the total period is 6 units. Done. If I want to use the rule, I can use the rule. The rule said take the fraction of the period, take the reciprocal of it. So what's the reciprocal of 1/2? The reciprocal of 1/2 is 2. Multiply that distance by the reciprocal, multiply that distance by 2. 3 times 2 is 6. That's the other way of getting it, just using the rule. Let's try another one. This one has pi's in it. I think we have, oh yeah, then we have to do equations. All right, I need to find the distance between here and here. I need to determine if it is half, a quarter, full, or whatever. So what do we think? A midpoint to a midpoint. Is that half, a quarter, a full? How much of a period is that?
No.
Half? I don't know. Daisy, what do you think?
I'm black. Give me a break. Look. Oh. Is it? It's not full.
So a full period, or again, you have to come from the top left down to the bottom right. So a full period would be between this point and this point.
What's with half?
So it is a half. This is a half of a period.
Is it always going to be a half, Mr. Snow?
It'll be a half or a quarter. I guess I should have done an example where it is a quarter. An example of a quarter would have been if I gave you this point right here instead. If I gave you that point, then it would have been even less than a half. It would have been a quarter. But we do have a half in this case. How long was that distance? We went from pi over 2 in the x-coordinate to 5 pi over 4. So I have to say, okay, well, let's 5 pi over 4. I have to subtract pi over 2. How long is this distance? Just subtract the rightmost point from the leftmost point. How far is that? Oh, gosh, we have to have common denominators. Oh, gosh, fractions. How do I get those fractions to have common denominators? They have to be the same. So what do I multiply this right fraction by? 2 over 2.
So it's 3 pi over 4.
Oh, she's already ahead of us. So yeah, 5 pi over 4 minus 2 pi over 2. And Rochelle correctly told us that 5 pi minus 2 pi is 3 pi. Oh yeah, that's teacher error. Thanks for catching that. Can you please log it? It should be 4 here. So 3 pi over 4. Rochelle was correct in saying that the total distance here is 3 pi over 4. So let's say 3 pi over 4. There it is. And we're almost done because we went 3 pi over 4, but that's only half a period. How much more do we need to go to get to the full period?
Another 3 pi over 4.
Another 3 pi over 4. So your final answer is?
6 pi over 4.
6 pi over 4, which can be reduced, right? Because 6 over 4, they're both divisible by 2.
Yeah.
So 6 over 4 reduces to?
3 pi over 2.
There it is. So 3 pi over 2
3 pi.
units. Boom, boom, boom. Wait, say that again?
Why did it be 3 pi because you have to multiply to 2?
We already multiplied by 2, right? We multiplied by 2 and got a 6. We used to have a 3 pi over 4. Now we got a 6 pi over 4. But then 6 pi over 4 was reduced to 3 pi over 2. Yeah. Be careful to not do multiple of the periods. All right, Daisy, ask a question.
I have to ask a question?
Do you have a question?
No.
Oh, you have everything down? All right, so that's graphs. So that's half of the homework tonight. The other half of the homework is on the back side. We have this general formula. And again, if I had time, I would be like, we'll play around with it. Let's figure out which of these letters affects period. We know letter H and K, that's shifted. H will make the equation move left and right. K will make the equation move up and down. A affects the, what's the word, the A affects? We talked about it up here. A affects the
amplitude.
Yeah, A affects amplitude. So the only other letter that we haven't really talked about yet is B.
And K affects the midline.
K affects the midline, yep. H will make it go left and right. B affects the period. So this affects the period. So if you're looking at the equation, look at the number attached to x. Ignore everything else. That's the only number that you need. So the other thing that you need to have in your summary, again, the first thing that you had in your summary was you needed to multiply by the distance by the reciprocal of the fraction of the period. To find the period for an equation this time, we just do this. The period, we'll just say P for period, is equal to 2 pi divided by that B. But again, period, just like amplitude, always has to be positive. So if you want to just give yourself an absolute value on the B, now you'll make sure that you're always positive.
So if it's negative, what happens then?
If it's negative, you take the absolute value and then it becomes positive. So you can say here, period is always positive. We did in our equation the absolute value of B, that way we have always a positive. So the period, just take 2 pi, divide it by whatever number was in front of x, you have the period. I feel bad that I wasn't able to let you naturally discover that on your own, but again, we are a little bit short on time. So let's go ahead and try this out on 3 examples. All right, so I'm going to write my formula. P is equal to 2 pi divided by absolute value of b. Oh, and she already gave us b. Rochelle said b is 3 pi because that's the number attached to x, so 3 pi. Absolute value of 3 pi is just 3 pi. And then Daisy, what's 2 pi divided by 3 pi reduced to? 2 pi divided by 3 pi. Pi should cancel out.
2/3.
There it is, 2/3. That's the answer. It's that easy. The period is 2/3, I guess I should say units. That easy. All right, Daisy, you're in charge of the next one.
Why?
Because Rochelle found the numbers in here, and you're going to find the numbers this time. So tell me what to write. What's the formula again?
P equals 2 pi over 3/4.
Over 3/4. Okay. And now I have to do that. So that's the same thing as writing...
2 pi over 1 times 4 over 3.
Oh, you already did it. Yeah. Divided by 3/4. And again, the rule is keep it, change it, flip it. Keep it.
Pull it. Slap it. Ew.
Pop it. Yep. Keep it, change it, flip it. Come on now. 4/3. And then we can get some things that happen that are nice. Maybe 2 pi times 4 is 8 pi over 3 units. The answer, done. I did go a little bit fast there, so I'll pause, make sure we can catch up.
No, that was good pace.
That was a good pace? All right. You're saying that just to make Daisy mad?
Yeah.
Oh.
I'm here for you, Daisy. We'll pause here as long as you'd like.
No, I'm good.
You're good?
Yeah.
Cool. Any questions on example 4?
No. Huge.
All right, then this is free game. You girls, tell me what to do.
What if we don't?
Well, someone's gonna have to do it.
Okay, so it's gonna be one.
No, you can.
Tell me what to write.
So it's gonna be. Hold on, give me one moment. It's gonna be -6.
Okay? Well, tell me how to get there.
So, P equals. Do I tell you like step by step?
Yeah, step by
or
step.
do I-
Yeah.
You can go nice and fast.
Okay. Pi equals 2 pi over 3. Negative pi over 3.
Negative pi over 3, like that. Okay.
And then I guess you can do it. I guess you can do the 2 pi over 1 divided by negative pi over 3.
Divided by negative
And then
pi
you
over
change
3.
it to multiplication, but you flip the second one. So it'd be 2 pi over 1 times negative 3 over pi.
Yep.
And
Keep
you
it, change it, flip it.
cancel the pi,
Pi's cancel out. Okay.
so then you just multiply 2 times negative 3, which equals -6.
This turns into -6 units. Did you put units and box it?
Yeah.
Okay, cool. That's it. Questions?
Wait, what?
Were you able to understand example 5, Daisy?
No, I understand that, but like, okay, never mind. Actually,
I bet
I didn't know that.
All right, there are two things.
Wait, Mr.
Oh.
No, but didn't you say that the period always has to be positive?
Oh, she did. Yeah, so that's an error. I'll give you some extra XP for that. So what should it be, Daisy?
It's positive.
Yeah, just scribble out that negative.
Don't tell me. I know. I'm just kidding.
It should be a +6 because we should have immediately, right from the get-go, taken the absolute value of negative pi over 3 to get positive pi over 3, which means that's positive, that's positive, that's positive, right there. Yep. All right. Any other questions? Good catch. All right, that concludes the notes.